So there is a chance that you have seen everything that we have covered so far in a math course or in a statistics class. Mean, median, standard deviation, and relative standard deviation. However, this is where this class becomes different because we're going to go further than this. And now we're venturing off into a field of statistics called confidence intervals and a couple of other equations that allow us to compare data sets to each other. So in this next portion, as far as calculation is concerned, it's probably going to be new to almost every single one of you, no matter your math background. So, one of the things that we're going to be talking about is something called a confidence interval. We abbreviate that as a CI value, confidence interval. It's not rocket science again, right? We try to make it self-explanatory. Next, we're going to look at a way that we can compare means. So for instance, if my laboratory does an experiment on a sample and we do a mean, and another laboratory does the experiment on the sample and they do a mean, are we really reporting the same number? Are we reporting the same story? Yes or no? We know that these numbers are going to be off. How far can they be off? That's the question. So we're going to look at how we can show that mathematically. We're also going to compare standard deviation. So if I had two people in the lab to do the same experiment multiple times, one person gives me a set of data, one person gives me another set of data, and I look at their standard deviations. Are they the same? Meaning, are my lab people as precise as they can be, or is one lab person more precise than the other? We've got a mathematical way of showing that. That's called the F test. A lot of times in the laboratory they call it the FU test. They think that's their way of, or that's your way of getting rid of them. And then finally we have what we call the Q test. And the Q test is a way that we can look at a set of data, question a point if it doesn't make sense, and maybe mathematically proving that we can get rid of that point because it was just so bad that it doesn't need to be in the data set at all. We know that it's bad, we know that it's messed up, we know something happened to that one in particular, so we get rid of it. That's why we call it the Q test in a way. Q, you think of question. So questionable point. That is what we're trying to kick out. So these equations, I would say, are no more difficult than the equations that you've learned so far with standard deviation and mean and median. However, the concept of these calculations can be something a little bit different. Okay, so we're going to start with the very first one, and this is called a confidence interval. So what's the story with confidence interval? All right. Let's say that I am working for a light bulb company. And it's my job to take a light bulb off the manufacturing line, take it into the lab, and test it. How long does the light bulb last? Okay. I'm going to do that multiple times. And I'm going to do that test on random samples or pulls from the manufacturing line itself. I go out, I take a light bulb randomly off the shelf, off the conveyor belt, take it into the lab, do my test on it, and I come up with the average lifetime of the light bulb. Well, I go out, I get another light bulb, bring it back in, do the same thing all over again. Well, over the course of time, as I test more and more and more light bulbs, I can get what we call a working average or an accepted average. Okay, so we get this term accepted average or mean. And this is something that I just know because I've done this test so many times over so many months or over so many years that I kind of get a good idea of the average lifetime of this bulb. Okay, well, we call that accepted because this is nowhere near the true average. A lot of times there's no way that we can calculate the true average of anything. So in order for me to calculate the true average of the light bulbs, I would have to test every single light bulb that comes off of the manufacturing line. Now think about that for a minute. I'm going to test every light bulb for its lifetime before I package it and send it out to you for you to buy. That means that I'm going to have to take the light bulb, test it, see when it actually blows out, and then when it blows out, put it in the box and sell it to you as a light bulb. No, that's just not going to work. We can't waste our product on that kind of mess. That's stupid. But that is how we would calculate a true average, because it's not really a true average unless we average every single sample in the data set. And millions of light bulbs are out there, and I've only tested a fraction of them. And somehow I'm supposed to relate this small portion of tested light bulbs to the entire manufacturing process. Well, we can come close, but how close, right? The accepted and the true values. They are close, but by how much? That's always the question that we have, and that is what we define as the confidence interval. We cannot calculate true means, but we can compare my true mean to a calculated mean. And this relationship is known as the confidence interval. Confidence interval. Let's look at this word interval. Interval means what? Yeah, it means a window. So what confidence interval will do is it will take the average and it will assign a plus or minus after it. And it will say, okay, this is your average. We have a plus or minus. And this plus or minus number, that's coming from your confidence interval. That's letting me know that the true value falls within a window. So let's say that my average is a 5 with a plus or minus 1 as a confidence interval. What that is letting me know is that this true average is 5 minus 1, which is 4, 5 plus 1, which is 6, and the true average lies within this window or this range, somewhere in there. I don't really know what the true average will be, but I know that it's going to be in that window of opportunity. My true value could be 4 exactly. My true value could be 4.5. My true value could be 5.67. My true value could be 5.99. My true value could be 6.00. I don't know. But this is confidence interval. How confident are you that the true average falls within this window or this range of numbers? So confidence is something else that we assign. And confidence interval, are you 100% sure that it falls within this window of 4 to 6? Okay. Are you 95% sure that it falls within this window, 4 to 6? No? All right. Are you 90% sure that it falls within this window or this range, 4 to 6? No? We can keep going lower. We can keep going higher. That's the term confidence. How confident are you that your true average, if you had to calculate one, falls within this window that you are providing? So there's a way that we calculate this, and the way that we calculate it is, again, another equation by a mathematician, and it looks something like this. So the U is what we call the mu symbol, or mer as in cow. So this is the mu symbol. The mu symbol represents the true mean. What is the true mean? And I calculate the true mean by taking my average that I have calculated based on my data set, x bar, plus or minus, this is where the confidence interval comes in. So T represents something that we call student's T, taken from table 4.2. I'll show you that in a minute. The S, which represents standard deviation that we just learned about, divided by the square root of n, which is the number of data points. And that is how we calculate confidence interval. I have to have the standard deviation of the numbers. I have to have the average. And I have to have this magic number called T, which I do not calculate. T is always going to be found in a chart for me. I just need to know how to read the chart and pull what I want from it. And n is the number of data points. So again, it's all of the pieces that we worked with before. No difference there. It's just a different type of equation that I put them into. And this is what we call confidence interval. So in the next video, we'll actually work out an example for confidence interval. And I'll show you the table and different things that we take away from the table. And hopefully you'll become more confident using the confidence interval. So until then, have fun. Read a little in the PowerPoints. Read a little bit in the book. You'll be okay. Just watch the videos.